Welcome! Today, we're diving into a topic that's, well, absolutely essential if you're making that jump from building models to actually running them in production. We're talking about AI and machine learning alerting. So let's figure out how to build a system that never, ever fails in silence.
I mean, just think about that for a second. It's a scary thought, isn't it? Your model, the one that performs so beautifully during testing, could be out there in the real world just quietly getting worse, making bad predictions and costing you trust, maybe even revenue. That problem is called silent failure, and today, we're going to build a solution.
All right, so here's the game plan. We'll start by really understanding the whole silent failure problem. Then, we'll build out our early warning system, figure out exactly what to watch for, check out the tools for the job, and finally, really master the strategy to make our alerting system top-notch.
So why does even a fantastic model need a watchdog? Simple, because the real world is messy. It's unpredictable. Data changes, what your users do shifts, and your model's performance can just drift away without making a single sound. And that's exactly where alerting comes in.
When you get right down to it, AI/ML alerting is just this, an automated system that taps you on the shoulder the second something looks off. It's not about passively logging errors. It's about actively turning all that monitoring data into a notification someone can actually do something about. It really is your first line of defense.
Any solid alerting strategy really stands on these three pillars. First, you've got to decide precisely what counts as a problem. Those are your triggers. Next, you need to figure out who needs to know when that trigger goes off. And finally, you decide how you're going to tell them. If you can get these three things right, you are well on your way.
Having a truly effective alerting system fundamentally changes how your team works. It moves you out of that reactive state, scrambling to fix things only after a customer complains, and into a proactive one where you're actually fixing problems before anyone even knows they exist.
And that whole shift, it's all about crushing one key metric, mean time to detection, or MTD. It's the average time from when a problem starts to when your team actually notices it. Without alerts, your MTD could be days, maybe even weeks. With a great system, we're talking minutes. Getting that number as close to zero as humanly possible is the entire name of the game.
And when you shrink that MTTD, you unlock all these other amazing benefits. Suddenly, you can retrain a model before its performance completely tanks. You have cold, hard data to justify rolling back a new version that just isn't cutting it. Ultimately, you minimize downtime, and that builds trust, not just with your users, but inside your own organization too. Okay, so we're sold. We need alerts. But the big question is, what specifically should we be watching for? Let's break down some of the most common and, frankly, most effective conditions that should be setting off an alarm.
What I love about this is how it covers the whole stack of potential problems. You've got your classic model performance stuff, like F1 score. Then you have data drift, which is basically the world changing underneath your model. You've got weird prediction patterns, really crucial bias checks, and of course, the health of the system itself, the infrastructure. A truly robust system is watching all of these things.
And this just perfectly sums up the central challenge here. You have to find that Goldilocks zone. If your alerts are way too sensitive, your team is just going to start ignoring them. That's called alert fatigue. But if they're not sensitive enough, well, you'll miss the very problems you're trying to catch in the first place. It's that constant balancing act.
All right, so how do we actually build this thing? Let's get into the nitty-gritty. Setting thresholds, picking the right tools, and getting everything hooked up.
When you're setting up triggers, you basically have two main choices. Static thresholds are the simple ones. Hey, alert me if accuracy drops below 90%. Super easy to implement, but they can get pretty noisy if your metric normally fluctuates. Dynamic thresholds, on the other hand, are smarter. They learn from the past. So an alert might fire if latency is suddenly way above the recent average. A bit more complex for sure, but way more robust against false alarms.
Next up, you need to pick your channels. A medium priority alert? Yeah, that could go to a team Slack channel for discussion. But a critical, the system is on fire alert, that absolutely needs to go to something like PagerDuty to wake someone up. And if the problem impacts your end users, a tool like StatusPal is perfect for public communication. The tool should always match the urgency.
And hey, for those of you coming from the MLOps course that this explainer is based on, you'll remember we use a simple library called Plier for local desktop notifications. This is fantastic during development, right? Letting you know when a long training job is finally done. But please remember, this is strictly for your local machine. It is not for a production environment.
Okay, we've covered the what, the why, and the how. Now, let's talk about some of the best practices that will elevate your alerting strategy from just good enough to truly great.
First things first, not all alerts are created equal. A critical alert means drop everything right now. A warning means, hey, look at this when you get a chance. And an info alert might just be for logging. This kind of categorization is absolutely essential for preventing burnout and focusing your team's attention where it's needed most.
And this right here, this is a rule that separates the pros from the amateurs. An alert that just says CPU is high is useless. It's just noise. A great alert says something like, CPU on the model serving pod is high. Here's a direct link to the dashboard. Suggested first step, check for an increase in request volume. See the difference? You're giving the person on call a clear path to actually solving the problem.
We've touched on this before, but it is so important it bears repeating. Your team's attention is a finite resource. If an alert fires over and over and nobody does anything, it's not a useful alert. It's noise. You have to tune its threshold or just get rid of it. You have to be ruthless.
Now we're getting to the really cool stuff. For problems you understand well, why not automate the response? If you detect significant data drift, your system could automatically kick off a brand new retraining pipeline. I mean, this is where MLOps truly shines, creating systems that can actually heal themselves.
And last but not least, please remember that your alerting system is a living, breathing thing. You need to set aside time to review your alert history. Which ones were helpful? Which ones did everyone ignore? Use that history as data to continuously tune your thresholds, your routing rules, and your messages.
So, I want to leave you with this one question to think about for your own projects. Is your alerting system just creating noise? Just another distraction? Or is it a powerful tool that's driving meaningful, proactive action? Because the difference between those two, well, it's everything. Thanks for watching.